morning and welcome back to the Coffee Break webinar series. My name is Eric Breitbach and I'm an applications engineer here with Data Physics. Today we're going to be talking about classical shock testing. The agenda for today, we'll cover setting up and running a classical shock test. Let's dive into it. From the manage test, we'll just hit new test. We'll give it a name. And we make sure we have shock selected. I'll mostly gloss over this first tab, but these metadata items are searchable in the Manage Test tabs, which can be very useful for finding specific tests. Let's move on to the Channels tab. I only have one ICP today, so I'll deselect my second one. And it is a TEDS Excel, so let's set channel 1 to be a TEDS sensor. From there, we just click Read TEDS, and we're set up. Let's move on. Let's set up our shaker. It's a 4-pound GWV4. So let's select that. And right here, I know that my device under test is 64 grams. This will be useful later for calculating limits. Let's move on. Here's the reference tab where we will define the test signal. Up on the top row, we have all of our engineering units. These are the defaults, as you can see, but we can change them to anything that is defined in the engineering units spreadsheet. Also on top, we can switch to velocity and displacement graphs, which are very useful when setting up the test. Let's look at the bottom right now, where we can see the pulse maximums and shaker limits. As you can see, the displacement is red, which is a visual indicator that the test parameters are well beyond the physical limits of the shaker. To fix that, we'll need to adjust our reference. The reference waveform has many classical options built in, as well as the ability to open any external file. I can pull from any save or from any ASCII file. Please note the tolerance limits change to user defined. We'll get back to that in a minute. Now let's go back to half sine. And I know for a fact that on this shaker, 6G amplitude and 5 millisecond duration will allow us to get closer to our displacement. Let's look at our velocity and displacement here. They're not looking too good, as we want these to be close to 0 at the end. To fix that, we're going to have to change our compensation. There's several different shaker compensation options that will instruct the shaker to move both before and after the shock event to allow motion within the physical limits of the shaker. I'm going to choose minimum displacement B. That will fix what we're looking for. I know that the options 3 and 15 for pre and post pulse amplitude will fix this pretty handily. Now the tolerance limits. DP900 software has many different common tolerances built in, and we're just going to choose the MIL 810 spec and click apply. And it looks like we're good to go. Let's move on to the control parameters. Up top, we have the option to autofill bandwidth and block size from our test settings. If you want to manually adjust these, you can just unclick this box and put whatever you want in. We also have the option to skip our stop switch test, which I'm going to click because I don't have a stop switch. Over here are the control parameters. Under that, we have the correction sensitivity, which controls how much correction is applied from one pulse to the next. We also have the control strategy, either frequency, time, or frequency and time. And then finally, we have linearity, which lets the software know how linear your shaker responds to corrections. This is typically used with hydraulic shakers, where you would use about 0.7 to 1. Over on the right, we have the pre-test parameters, which we have another coffee break webinar going in depth about these. Switching to the signals tab, I'm going to gloss over most of this here, but these are the signals that you will be able to see in the test. You can also set up exports in the lower right. Lastly, the run scheduler. tab allows us to define the stages of the test. By default, it has several defined stages, each ramping up in intensity. Each level of signal improves the control correction so that when the fully scaled shock event stage is reached, it is the correct shape and amplitude. Let's look at the rest of these columns. Over here we have stage, we have type, level, number of pulses. These are all fairly straightforward. The number of loops is only applicable to the loop type of stage. The manual column lets you define more control in case you want to stop and check the test article after each shock event. We'll click it for the last stage and see how that changes things. Period is the time per pulse. Polarity is the direction of shock. Correction instructs the software to apply pulse shape correction after each shock. It can be useful to disable this if you want all shocks for a stage to be the exact same shape. Save rate defines how often you want the software to save. A rate of 1 that means that every pulse will be saved. Rate of 2 means that every other pulse, and etc. Enabling the abort option means that the software will stop the test if the abort tolerances are exceeded. Let's go ahead and run the test. All right, so from here I can hit initialize, and that's going to push the test down to my 901. Click continue. And I'll click start to start the test. It's going to go through the pre-test right now. And my pre-test passed. That's fantastic. Let's go ahead and start the test. And we can watch as it goes through the various levels, the various stages. So we had -9, now we're at -6, now we're at -3. We'll get to 0 at some point. And since we clicked manual control, it's going to make us click the up button here. That's going to continue. So you see we're going through. And every time I click this button, it is doing a single pulse. And there we go. Now, I had the last stage set to be manual, so I can just continue with this for as long as I want, or I can click stop and end the test. I think I'll end here. Thank you for watching this short coffee break webinar. For more useful tutorials on how to get the most out of your 900 series software and analyzers, please visit our YouTube channel where we post these and longer form tutorials and videos. You can find more information about our products on our website, dataphysics.com. Thank you.